internet because it was going off. All right, everybody. Today is another fun-filled day with Coffee with Mr. IoT. I'm Rachel Mormon, and my co-host Robert Schmid and I are lucky to talk on a really interesting topic today. We're going to talk about the environment and Dr. Allan Zarembski. I'm probably totally butchering that, Alan. So can you correct me for a second?
Okay, it's Professor Allan Zarembski of the University of Delaware, yes.
So tell us a little bit, what brings you to our show? Why are railroads and environments an IoT hot topic now?
Well, my field is the area of railroad engineering, and specifically railroad track maintenance, planning, and management and safety. And we're similar probably to a lot of industries that have incorporated technology to, more than incorporated, we've embraced technology, particularly in the inspection of the railroad track. So look at the scenario. The United States has 200,000 miles of railroad track. You know, and we have multiple systems that are coming along and collecting kilobytes or in some cases megabytes of data per foot of track. So, you know, you look at 5,280 feet times 200,000 miles. Then if you're talking about rails, you can multiply that by 2 just to make the number even more impressive. And you can see all of a sudden we find ourselves deluged with data, buried in data. And so what do we do with it becomes a real question, you know. So for years we've always done the simplistic stuff, putting single thresholding techniques in there so that if something pops beyond the threshold, you know, it gives an alert and say something's wrong, and we go follow. But you know, that's sort of scratching the surface. And so the whole what has led the industry to IoT, or the other term that we like to use is big data, and the big data analysis is to see if we can mine this information and come up with techniques to improve safety, improve the efficiency of the operation, make more effective use of our resources, and again, given the fact that most of the railroads in the U.S. are private, and therefore for profit, the other ones are government owned and barely able to support themselves, always struggling for money. The issue of trying to optimize our track maintenance and to optimize the whole area of railroad engineering becomes really, really, really important. And so that's what brought us into it.
Wow. So I mean, I'm a Philadelphian myself, so I'm a big fan of the Northeast Rail Corridor. I take it quite frequently, but I'm still surprised. You know, a lot of people share the tracks. There's still delays. Is this going to help? Is any of this data going to help with that? I'm selfish. I want to know how it's going to help me. What's the future of optimizing this from a speed and efficiency perspective?
Okay. So if we take a step back and we talk about the railroad industry in general, as opposed to my narrow specialization, which is the railroad track, there are all sorts of opportunities to improve operations, improve scheduling. But to answer your question, let's go back and zoom in my area. If I can eliminate the delays due to track maintenance, if I can reduce the cost of track maintenance so that you have fewer bumps along the way, so your train can maintain higher speed along the way, so that we have fewer delays along the way. And even more important, you get rid of the once in a blue moon occasional accident that happens. Then I just made your life easier, more convenient, and safer. All of which I think would be attractive to you as a native of the Northeast Corridor.
I have a question for you. Can you guys hear me okay?
Kind of. Well, I'll repeat it if we can't.
Okay. So I'm European, and there is the French fast train that goes, and then there is a train that we're talking about today from LA to San Francisco. Is this going to help us getting faster trains in the U.S. too? And is it just my question, or are we somewhat behind in the U.S.?
So I think what you asked, Robert, is is there's a high-speed train in Europe, obviously, and there's talks of one in LA to San Francisco. And are we behind in the U.S. compared to our European counterparts who have all those fantastic high-speed trains that we so dearly wish we had? Like one from LA to San Francisco, which would be awesome.
This is one of the classic questions we always get asked. In fact, I will say that almost every newspaper or TV interview I get asked on, that's one of the top 2 questions you get asked. Why are our trains not as good as the European? Well, the question, it depends about which trains you talk about. If you look at how the World Bank rates railway systems, the United States has absolutely the best freight railroad system in the world, bar none. And that's not me speaking, that's the World Bank speaking. It happens to have a mediocre international passenger system, or national passenger system, to be specific. This is your high-speed operations. There are a variety of reasons for this, which we can take. I'll give you the 10-second overview. We're a very large country. Our inter-urban distances are very great. Even if you had a 200-mile-an-hour train, you're still not going to go from Los Angeles to New York by train, because it'll still take you the better part of a day, and that's with a minimum number of stops, whereas you can still fly it in a fraction of the time. So right now, a 200-mile-an-hour train is still a lot slower than a 600-mile-an-hour airplane, especially when it's nonstop. So the long distances do not lend themselves to a national rail service of any great extent when we have a really first-class air system service. Places where we have European-class distances, like the Northeast Corridor, we actually have a decent system. Why are we not as fast as the Europeans? Well, a lot of that has to do with money. The Europeans have spent a lot of money. High-speed rail is not a money-making operation. High-speed rail requires a large investment of capital, and we as a company have not made that investment, so that we do not have that ability to do that. I've got somebody at my front door. You're going to have to give me a 2-minute break to see who that is. I really apologize. I have no idea what just happened. Give me
okay, I'll make fun of Robert's lack of voice and just tease him endlessly since he can't fight back then. Because I've always wanted to do that, Robert. I don't know why. It just makes it so easy.
Because I can't speak back. Is that what happened?
Yeah. Wait, what was that, Robert? I'm sorry. I couldn't hear you. So
I'm curious why you spend months investing into your training if it's not a money making.
Yeah, I didn't get that. I think I'm excited to ask Allan, though, if there's anything that's unexpected coming out of this data. But we'll see when he gets back.
I'm back. Sorry about that. Okay, so just to go back to the question of why don't we have a good railway system, our freight railway system is the envy of the world. Our freight railroads are so good that Warren Buffett spent, what, $25 billion to buy the Burlington Northern Santa Fe, and I think most people think he's a fairly savvy money person. Yeah. So our freight railroads are extremely good, and like I said, the World Bank rate us as top in terms of any of their measures that they use for productivity and efficiency and effectiveness. So as a country, we have put our railroad resources more on the freight side than the passenger side. Now, are there going to be moves to increase the passenger operation? Sure. You're seeing California doing it right now, and commuter rail is booming, and metros are booming, and I consider metros all part of my industry. So when we're talking about intra-urban, which means within the city type of metro systems, they're booming, and all of these to bring us back to IoT have the same issue. We collect lots of information, we collect lots of data. We have, for example, every railroad has, a large railroad will have 2 or 3 high-speed dedicated track inspection cars that collect information every foot along the track at a very significant rate. In fact, now they've added video to it, so in addition to all the digital data and all the instrumentation and all the measurements, and so we've suddenly been forced into the big data world in a very big way, and we're trying to make use of it.
So you sit with your professor, so I'm guessing you have students with new crazy ideas. You've got all this data coming your way. What are some of the things you're seeing that are unexpected? So maybe you captured the data and you started looking for insights, but new things popped up, or applications or applicability of that data that was outside of the original intention.
Okay, I just finished the research project sponsored by the U.S. Federal Railway Administration, which was a big data application where we used 5 years of data from a railroad that had about 20,000 miles of track, and which inspects the track maybe 3 or 4 times a year. And what we found was we found some interesting cross sensitivities that we didn't expect before. For example, we had types of problems that come up in the track that need to be maintained. You have rail type of problems that are associated with the rail, and you have geometry type of stuff problems which are associated with how level and how straight the track is and how many bumps you have in the track. You know, that's the sort of stuff that causes your coffee to spill, for example, if you're in the Northeast Corridor. And what we found, for example, is that if we address geometry defects, we might actually be able to reduce the rate of development of rail defects. Now, rail defects are particularly scary because when a rail breaks, it usually causes, it has a very high probability of a derailment. So it has a higher probability of a derailment than any other. It's still a low probability of derailment. We get, but again, to give you an idea of the numbers, because this is why we're in the big data world, we have 200,000 defects a year, rail defects a year in the United States. And we have 200 broken rail derailments. So it's a rare occurrence, but 200 broken rail derailments at $500,000 each is still something we worry about. So if we find that by addressing geometry defects, we can do that, that's great. But the obvious question is, well, we can't address every geometry defect all the time because that becomes unreasonable. Can we use big data techniques to identify unique signatures or unique parameters that says this location, these geometry defects have a greater chance of causing a rail defect? And we did that. We came up with some we actually came up with some identifiers that said if we find these 4 characteristics in a geometry defect, the probability that a rail defect will develop there is 88%. Now, 88% is worth doing something, so that's an example of how big data led to some very practical applications. And so we have, and that's one of the reasons why we have our big data conference, which we run once a year. We have.
Well, let me just pause you for a second because I do want to talk on that for just a second. But for those who just joined, you're watching Coffee with Mr. IoT. Our guest is Dr. Allan Zarembski. I'm going to get it right at the end of this, and he's a professor focusing on the railways. And we're talking today on how IoT has enabled some really cool things. And really, let's talk about the data. Why is this exciting? Why are people getting together for a conference? What are some of the hot topics that are coming up? And tell us a little bit more about the conference.
Okay. Well, as I said, the sort of the theme of the conference is how do we mine the mountain of data we have to get usable information? Everybody in the IoT world understands the distinction between data and information, particularly usable information. And we're no different in the railway industry than any other industry. We want to convert our data into actionable information, things that we can really do something about that are effective and cost efficient and improve safety or efficiency or whatever the parameters that we're aiming at. One of the things that we've done is we've started at the University of Delaware. We now have an annual conference. And the conference is Big Data in Railroad Engineering and Maintenance. And we have grown. In fact, we're in our 3rd year now. We have the conference coming up on December 15th, 16th of this year at the university, which is in Newark, Delaware. And year 1, we just thought we'd have a little seminar. And we thought we invite some railroad people and some IT people to chat some ideas about, we thought, we'll get 30, 40 people and that would be nice. And we have a nice discussion. So we put out an invitation and 100 people showed up. And we literally ran out of space in our meeting room. So when we did it again the second year, we said, okay, well, let's plan on 100 people showing up, and we had 220 people registered. In fact, I had to go scramble to find alternate space because our room was nowhere near big enough to handle the crowd that we had. And so this year, I'm budgeting for about 200 people. We'll see how many people show up. But what this tells me is that there's real interest. And we had users, we had data suppliers, we had data analysts, we had big data people, we had IoT people, we had IT people, and each one of those will have their own unique view of the issue. So we had the railroad users who have the data and want to figure out how do I use it better. We have the people who supplied all the measurement equipment that collects all this data, and then we have the IT people who are tasked with, okay, how do we analyze it? And we also had a subset of university types, like myself and others, whose focus is on how do we develop more leading-edge, cutting-edge methods of analyzing this data. And I will make a comment, by the way, that while I'm at the university, I'm relatively new to the university. I spent 40 years in the industry, and I only came to the university in 2012, so I've only been in the university for about 4 years. And before that, I was on the working side of the business. So I have both perspectives. I've always had the theoretical end, and I've always been on the analytical side. But I've also been on the side that says, what do I do with this nice theory, and how do I make it useful? And so that's very important to me. And the fact that we can bring people together to address that issue is significant.
Allan, this is awesome. I hope you can do this. I have a question for you. Are you riding the train yourself? And what makes IoT, how does IoT make riding trains work better than other people?
Okay, I think, Rachel, you're going to have to translate.
Okay, so I know it's he's going personal because I could tell something about what he's asking, I think you asked if he uses the train, and what was the other part of that, Robert?
What makes, how does IoT make the rider's experience better?
Oh, how does IoT make the experience better? How does it improve our rail experience? But also, I want to know, do you ride the rails yourself? Are you constantly looking for applicability based on your own personal usage?
I ride the rails myself, yes. Of course, from my point of view, I've ridden probably as many freight trains as I've ridden passenger trains, and I've ridden as many inspection cars as I've ridden both. So, I'm definitely not your normal rider. But let's take it from a rider's point of view. And again, no, let's take a step back. Let's take it from a consumer's point of view, because I'm going to broaden it. Because remember, I said that the railway industry in the United States is heavily freight. Just about everything you use, from your electrical power to your automobile to your breakfast cereal in the morning, has a rail component to it. Automobiles are delivered almost exclusively by rail. The reason you go to your car dealer and you buy a new car and you look at the odometer and you see 23 miles on it is because it was shipped by rail from the from the port or from the assembly plant to the to very close to the local dealer, and only the last couple of miles were driven or shipped by truck. A significant amount of the power you have is, or still is coal generated. Coal is still a big, coal is only moved by rail. You can't move coal any other way. Grain, we move grain products by rail. So all your cereal probably originated in grain movements, which are big rail. Steel products, all your ores are rail. So you don't just have to be a train rider to be impacted by the railway industry. So having said all that, how is my experience improved by IoT? What we're hoping is IoT will allow us to look at our data more efficiently to make the system more safe. We're a very safe system, but we're not perfect. We do get derailments, and most of the time people know about it because railroad derailments tend to make the TV news a lot. So we're looking to make the system safer. We're certainly looking to make the system more efficient. We're looking to make the track smoother. We're looking to make the operations better. We're looking at the way we run trains more efficiently, be it passenger or freight. And that in turn makes for a smoother ride, and more important, or not more important, but also important, is a economic operation of the system. So your costs, be it fare as a passenger or the cost of your cornflakes in the morning, is reduced because the cost of transportation is low.
So we talk to a lot of people in industry, in different industries, and they talk about what they hope to see in the future as it relates to IoT enabling new functionality, new capabilities. What kind of things are you looking for in the future? Are there new sensors that you wish the trains had today that would enable kind of more advanced involvement in either safety or efficiencies or comfort? Or what's the next step? What do you wish we had now, or what do you foresee in the future that you're excited about?
So let me give you a specific example that's in the process of being implemented right this minute, and that's what we call positive train control. Positive train control is a technology that combines GPS-based positioning information mounted on each train with wayside sensors that allow you to know exactly where each train is, how fast it's going, whether it's getting too close to another train or getting too close to another piece of equipment, or whether it's going too fast for a section of track, and allows the system to take action if the train engineer or the train driver can't or is unable to. So this is a technology that is literally has been mandated and is supposed to be in effect with it by the end of basically 2018. And it combines, now we're talking about thousands of trains running around the country at any one time, and we're getting instantaneous readings of their location, their speed. We're getting other things like what are the forces in the train, what are the condition of the locomotive. There's other nice information that's coming out. But this is something that's a measure that will, A, improve safety. So if a train is going over speed and something happens with the locomotive, and that, by the way, there was a recent, there have been a recent major derailment that caused because that happened. It will automatically slow it down or stop it. It will make the train operation more efficient. It will make the train operation more fuel efficient. So we will now conserve resources because we can now look at optimization of the speed with respect to the train versus all the other trains around it. So we can start looking at the railroad as an integrated system. We can make more efficient long-term meet pass, so the trains have to meet downstream. We can make that meet more efficient, more smooth, so that you sitting in your passenger train doesn't have to come to a stop because there was another train ahead of you and you had to wait for it. All of a sudden now you can see a little bit more ahead of yourself, and you can see, I can do this. I just, maybe I'll slow the train down a little bit so I don't have to come to a complete spot. But your ride becomes smoother, more comfortable, more effective. And this is a technology that is in the process of being implemented as we speak.
Awesome. I wish we had more time, because I'd ask you about self-driving locomotives, since self-driving cars are there, our locomotives next. But unfortunately, we're coming to the close. So thank you so much, Allan. We really appreciate hearing not only what's coming up in the conference, but also I think probably the best part for me is kind of the stuff to look forward to as early as 2018, something that's going to be so relevant to our day-to-day rail usage. And like I said, I'm a big fan of riding the train here in the Northeast. So if you missed any of our talk today, please visit our YouTube channel and stay with us every Friday, next Friday included, 9 Pacific, 12 noon Eastern. And we'll have another great coffee with Mr. IoT Chat. Lots of fun guests coming up our way. I don't want to spoil too many of them, because I know there's some that we're working on that you guys should be excited for. But Dr. Allan, thank you so much for joining us, and good luck at your conference. I hope you find some new insights that you never expected before, and have a great day. Very good. And I invite any of your participants. By the way, our conference is free. We don't charge
registration free. So I invite anybody who's interested, go on the web. You can find the information. You can contact me directly, and I'll be glad to give you registration links.
Perfect. Thanks, everybody. Have a great day.